All right, so this video is for if you missed today's Zoom class on Wednesday, September 23rd. All right, so a general reminder is that we have a quiz on Friday on lesson 2.1 to 2.8. And on here, to find your quiz study guide, just log on to Schoology. On the main Schoology page, scrolling down to September 23rd, Wednesday class materials, if you go ahead and click on lesson 2.1-2.8 quiz study guide, you should be able to find this study guide here. If you want to print yourself an own copy or this view is too small, you can go ahead and select this button on the upper right hand side, and it'll open it up for you in Google Docs. So a couple of things that you should know is that one, something that I added for your study guide are the links to the lessons that we all covered in Unit 2, right? So here are the slides. So lesson 2.1, all these descriptions are the slides. And then these are the Nearpods that we did on those days, right? So they're all in one place. So if you need to go back and look at any notes or definitions or things like that, you can do that here. In the basic section, it's basically like a fill in the blank on different terms that you need to know. And the sentences give a brief summary of what we did from lessons 2.1 to 2.8. So starting really easy with the terms you need to know and kind of what we did in these lessons. If you scroll further down, in the proficient section, you'll see practice problems that you'll probably find on the quiz. Okay. All of these questions are optional to complete, but they'll be very similar to what you see on your quiz. And tomorrow, aka Thursday, September 24th, I will release the answer key to you in class. All right. Okay. So in today's lesson, we mainly talked about atoms, and we discussed briefly the history of atoms and how atoms work. Right. Okay. So on Monday, before this lesson, we had talked about we are made up of a mixture of things. So there's us, and there's all these little pieces that make up us. We call them substances. So this one is one type of substance, and here we have a different type of substance. And if I zoom in closer to one specific substance, we call this a compound, mainly because it is made up of more than one type of elements bonded or combined together. And if I zoom in further and break apart the compound, all I'm left with are the types of atoms. So this is the building block of our universe, and this is what makes up our universe. So we have to understand what this circle or sphere actually looks like, right? So that when we know what it looks like, we can work backwards and build up whatever compound we want and whatever mixture we want. In real life, when I say we're building a compound, we're basically making like a new molecule or a type of medication or something like that, right? So that's why we're here in medical chemistry. So before we actually build any of those things, we have to understand how an atom works. So in the Zoom class, I went over the history of the atom very, very briefly and shortly. So in general, we thought of the atom as tiny, tiny spheres or balls, right? So here, when we first started thinking about this, we were like, oh, what happens if I cut up stuff into tinier, tinier pieces? Well, if I continually do that, eventually, all I'm left with is like a tiny version of that thing. And then later on, we realized that there was much more to it, right? So we briefly went over some of the experiments until we realized that, hey, this is actually what an atom looks like. So let's go over a couple of these experiments. These experiments are just general background knowledge. You don't have to actually know this information for this course. All right, this is just to give you a background idea of how we came to this conclusion. All right, so one of the early models of how we figured out what the atom looked like was called Rutherford's gold foil experiments. And in his experiments, he basically took kind of like aluminum foil, right? But except instead of made out of aluminum, it's made out of gold. And he shot a whole bunch of radioactive particles at it. Excuse me. All right, so he's shooting particles or energy lasers, however you want to think about it, at this sheet of gold foil. Now, these things that he's shooting at are really, really tiny. And he found that 99% of these really, really tiny things went straight through the gold foil, which is kind of weird because if you think of the atom as a ball filled with stuff, well, if you hit something that's a ball, it should bounce back or at least bounce off in a different direction. But he found that 99% went straight through. So, since that's kind of weird, right, he made another hypothesis or a guess that, oh, what if the atom is mostly empty space, right? And that would explain why most of these particles went straight through. On the other hand, what happens to that 1%? Well, 1% of them would bounce off to the side, just as expected. So from his data, he also guessed that whatever that 1% is, it's big enough, just big enough to block or deflect the radioactive particle off to the side. So there must be something small and there must be something small and very tiny in the middle of atoms. And everything else around the atom is just kind of empty space, right? Another experiment that was discussed was J.J. Thomson's experiment where he discovered what an electron was. So in this tube, for his experiments, he took out all matter. So there's absolutely nothing in this tube, not even air. And what he did was he essentially electrocuted the tube to see what would happen. So here, when he did that, he found an extremely weird looking green light and he started messing around with it. And specifically, when he messed around with it, he saw something like this. So here, he put a magnet to it. And this magnet has a negative charge, right? So here I asked the class, this thing that's in here, what charge do you think it is? And just to recap how magnets work, if you recall, magnets have a negative end and they have a positive end, right? And for magnets, opposites attract. So here, if I have a negative end of a magnet, these two things will want to be close together, meaning they will attract. So opposites attract for magnets. And if they're the same charge, so if I had two magnets that were both negative, they would push each other apart. All right. So here, if this one's negative and the light is going away from the magnet, what do you think the charge of this light weird thing is? If you guessed negative, you are correct, right? So the light is bending away from the magnet. It wants to push away from the magnet. So if this magnet end is negative, this thing, whatever it is, has to also be negative. Okay, so from this experiment, J.J. Thomson discovered something called the electron. So he knew that whatever this thing he found used to be attached to the atom, and it's this stuff going on the outside, right? Okay. So after that, we did one more experiment talking about how we figured out that atoms moved in this ring-like orbital or shape, right? How do atoms move in this ring-like orbital or shape? It's the same way we use fireworks, right? So basically, I burned a couple of elements and it showed up there as very specific colors. So if you take calcium and you burn it, it'll show up as orange. If you burn lithium, it shows up as red. If you burn copper, it shows up as green. And if you check our class Instagram, you can see one example of copper turning green, right? And so when we did this experiment, I'm going to skip forward a little bit. It basically helped us out in terms of figuring out that electrons move in rings. And the reason why we move in these rings is because if we split the light that we saw coming from the flame, there were all these little lines showing the different energy levels of the rings, right? And in each energy level, you can fit one electron. Excuse me, not one electron, two electrons. After that, we watched a video explaining that if we know what colors different elements give off, we can figure out what elements are on different planets in order to identify what planets are habitable and so on. So all of that was just general background of how we currently discovered what the atom looks like. But mainly for this class in this lesson, what you do need to know is that if you're given one specific type of atom called an element, how would you draw that in its atom form, right? So a lot of you from Monday's homework were able to figure that already, right? So at this point, we did a Nearpod, the usual Nearpod lesson. And let me walk you through that Nearpod lesson as well. So going back to Schoology on my Schoology page, right, I'm going to go to my main page again. Scrolling down to where it says week 6, September 23rd, Wednesday class materials, clicking on homework. When I click on homework, most of this is the same as our other Nearpods. So the lesson you mainly need to complete is your Nearpod lesson 3.4. Right. So again, this is the title of your notes, the key ideas for the video notes, the link to the Nearpod lesson, and the code you need to input to access your Nearpod lesson. Scrolling down, if Nearpod is lagging, you can copy and paste this onto a new tab. You should be able to this, and then you should be able to see the slides that you would normally see on Nearpod. Right? Okay. Something that's new that I can't show you on this view because I'm on the teacher view, and even if I use a student to go to student view, it doesn't show up, is that there should be a document called Bohr Model Homework Practice. On your version, you should see a button that says My Documents up here where mine says In Progress and Submissions. You should see something that says My Document. Go ahead and click on where it says My Documents, and then go ahead and click on Edits on the right-hand side. It should show up here after you click on My Documents. So first click on My Document, then click on Edits, and you should see this Documents where you can edit. So the goal for you in this class is to draw the Bohr model of the element that I give you on this left-hand column. All right. Now, drawing things digitally might be kind of complicated. So if you click on this link, it will show you a video of me explaining how to draw digitally, explain on how to draw the Bohr model digitally, right? So basically, just like the video lessons in Nearpod, how would you draw the Bohr model of an atom? How would you draw the Bohr model of lithium here on my left-hand side, right? So this is the second part of your homework. The first part of your homework is your Nearpod lesson. Hopefully that was helpful. If you need anything else, please do not hesitate to email me or direct message me on our class Instagram page. And the handle would be at Quan, Quan, Medchem, Medchem. No space, no underscore, anything like that. Just at Quan Medchem. All right. Have a great day, y'all.